in some of the earlier videos, I gave you a problem similar to this. I gave you one where we replace the sweets. So here we've got a bag of sweets. They're all identical apart from the color. If I were to take out two sweets, what is the probability of the two sweets being the same color? Well, we have one scenario where we would take out the sweet and then take note of the color. Let's say purple, and then we would put it back. We would replace it. We would put it back, give it a shake, and then take out another sweet. And then then we would ask ourselves, what would be the probability of these two sweets being the same? And then I gave you another scenario where we don't replace. So we're going to take out two sweets here. Let's say take out this sweet here, and then take out another sweet. With this scenario here, we are not putting the sweet back and giving it a shake the second time round. So with this one here, we would take out a sweet, put it back, give it a shake, and then take another one. With this one, we're just going to take one out and then take another one out. Okay. Now there is a difference between the two. If you draw a tree diagram for this scenario here, the replace, it would look something like this. Hang on. It would look something like this. So on your first pick, you could get a purple or a white one, and then on your second pick, you could get a purple, white. Well, it would look like this. Same as over here. Okay. On your first pick, you could get a purple or a white, and then on your second pick, you could get a purple or a white. So far the two scenarios they look the same, but let's have a look at the replace. Let's say we pick out one. Let's say it's a purple one. So we've gone down this route here. Now the probability of us getting a purple would be 3 out of 9. The probability of us getting a white one would be 6 out of 9. Now with this scenario where we replace, if you've just picked out a sweet. Now you would put it back, give it a shake. Now the probability the second time around would be 3 over 9. Okay, because you put the sweet back and then you've given it a shake. So the probability of you getting a white one would be the same, 6 over 9. So here, it would be the same like this, 3 over 9 and 6 over 9. Now look at the scenario where you don't replace. So we're going to take out a sweet, sorry. So the probability. So hang on, let's go back to the beginning. So here we are here. We're going to take out a ball. What is the probability of us getting a purple one? Well, it will be 3 out of 9. The probability of you getting a white one would be 6 out of 9. Now let's say we've taken a purple one out. Okay, so this one is gone. This purple one. Now come our second pick, the probability of us picking a purple one will change. It would be 2 over 8 because we've just taken out the purple ones here. We've just taken this one out. Okay, so this one here goes. So what's left would be 1, 2, 3, 4, 5, 6, 7, 8. That's why it's 2 out of 8 for the purple one. Now the white one would be 6 out of 8 because there's still 6 white sweets remaining. So my point is that this is one event. This is another event. Now this event here is dependent on the first one. So this scenario is the event in this scenario here is dependent. Is a dependent event. This one here. This event here is this event here is independent of this one here because this event here has nothing to do with the first event. Whereas if you look at this one here, this event here is dependent on this event here. So with this scenario here, you have the second event is dependent on the first event here. This one here, the second event here is independent of the first event. Okay, so take note of that. Let me give you some more examples. Let's say you've got a a drawer full of socks. So here you're going to you're going to pick out 2 socks at random. What is the probability of those 2 socks being the same color? So here your diagram would look something like this: purple, white, purple, white, purple, white. Now on your first pick, the probability would be 4 over 12. The probability of you picking a white one would be 8 out of 12. Okay, let's say you've gone down this route here. You've just picked out a purple one, a purple sock. And now the probability of you picking out another purple sock. Well, don't forget we've just picked out this one here. Okay, the probability of you picking out another purple sock would be 3 out of 11. Okay, the probability of you picking a white one would be 8 out of 11. Can you see that this event here is dependent on the first event? So had you gone down this route here, the probability here would be 4 out of 10. The probability here would be 7 out of, sorry, this one's 4 out of 11. This one here would be 7 out of 11. You see, my point here is that the second event, which is your second pick is the second event. So my point here with this scenario here, the event is dependent on the first event. If you roll a die, let's say, if you roll 2 dice, well, rolling 2 dice at the same time is like you rolling 1 die and then rolling another die. You see, you rolling the first die. Well, here the 2 events here. This is your first die here, and this is your second die here. With this scenario here, the 2 events are independent because what you get on this die here has nothing to do with what you get on this die, or what you get on this die here has nothing to do with the first die. So with the dice scenario, the events are independent. The sock here scenario, the 2 events are dependent. Now, if you look at up here, this scenario here without replacing is dependent. This one here without replacing, the 2 events are independent. Let's have a look at another scenario here. If you have a packet of playing cards, if you pick out 2 cards at random, what would be the probability of these 2 cards having the same suit? Let's say hearts. Okay, so here picking out a card around, picking out 2 cards at the same time is the same as you picking out 1 card and then picking out another card. Okay, now in this case, the 2 events here are dependent. So for example, if you pick out a card here, you could get hang on. First time around, first time around, you could get 1 of 4 events. You could get diamonds. Hang on. Let's use diamonds, clubs, spades, spades and hearts. Okay. But because we're only interested in hearts, we're going to simplify this diagram. Let's simplify it to hearts and not hearts. Okay, just merge those 3 branches into not hearts, and then so the probability of you picking a heart would be here. You've got 13 cards, 13 out of 52. Not hearts would be, well, it would be 39 out of 52 because 13 here, 13 here, and 13 here. So yeah. Well, anyway, so this branch, this represents your first event. Now come your second event. Well, hearts and not hearts. This one here, heart. Sorry, not heart. This one here is heart and not heart. So here, so suppose you picked a heart on your first pick. The probability of you picking another heart would be 12 out of 51, because you've just, so suppose you just picked out this 4 here. Now, on your second pick, there's only 12 cards left. 12 hearts left out of the 51 cards. So here you can see that this event here, this event, the second event, is dependent on the first event. So here the probability of you getting 2 hearts will be this and this. So you would get this times this. But don't worry about understanding this for the time being. I will give you some more examples here in the next video. Okay.